A normal distribution curve is a way statisticians describe how values tend to spread out around an average. You've seen this pattern before, even if you didn't call it that. Think about heights, test scores, or small measurement errors. Most values are close to typical, and values far from typical are rare. When we graph this pattern, we get a smooth, bell-shaped curve. That's why it's often called the bell curve. The formal name is the normal distribution curve. It's perfectly symmetric, meaning the left side mirrors the right side, and the highest point sits right at the average. That average is called the mean, and it sits at the center of the curve. In a normal distribution, the mean, the median, and the most common value are all the same point. The spread of the curve is controlled by something called the standard deviation. A small standard deviation makes the curve tall and narrow. A large one makes it wider and flatter. The curve itself is not a bar chart, and it's not counting individual data points. Instead, it's a model. The key idea is that probability comes from area under the curve. The entire area adds up to 1, meaning 100% of all possible outcomes. The probability that a value falls within a certain range is found by looking at how much area lies between those two values. This leads to one of the most useful facts about the normal curve, called the empirical rule. About 68% of values fall within one standard deviation of the mean, about 95% fall within 2, and about 99.7% fall within 3. This gives us a fast way to judge what's typical and what's unusually far from average. Normal distributions matter because they show up everywhere in statistics. Even when raw data aren't perfectly normal, averages of many measurements often are. That's why so many statistical tools rely on this curve. One last thing to be clear about. Normal doesn't mean good or ideal. It's just a name for this specific shape. Not all data follow it, and that's okay. In short, a normal distribution curve is a symmetric, bell-shaped model centered at the mean, shaped by the standard deviation, where probabilities are read as areas under the curve.